Motor Lab by Kieran Trevino. So what is a motor? A motor is a variation of a machine that is powered by either internal combustions, like in cars and trucks, or electricity, such as batteries. Motors are in nearly everything and anything that we use. In fact, close to 70% of the electricity that is produced on this planet is consumed by motors. Some examples of electric motors are CPU models in laptops, refrigerators, washing machines, and windshield wipers. Materials. The material we used in the experiment included 1 D-volt battery, 2 metal paper clips, 1 rubber band, 1 modified conductive coil, and 1 magnet. To allow for the electricity to flow through the paper clips into the wire, creating the momentum and spinning rotation, we had to modify and bend the paper clip in order to rest the coil on them. We also used 1 piece of sandpaper in order to sand both sides of the coil. The coil itself we modified to create more rotations. In the beginning, we made the coil a large square, not considering the slow RPMs the object would have, inevitably leading to a halt in the motor's functionality. We were forced to make the coil smaller and more compact in order to allow quicker rotations and a more reliable motor. These are the edits we made throughout our lab. Alright, so this is my simple motor explanation. Right here we've got the gyroscopic force within the coil. This is causing it to constantly rotate forward. This is where the current enters and exits. This is the magnetic field caused by the magnet down here, and this is the North Pole facing up. So right here on this diagram, you can see, as you can see, the coil points diagonally because a magnetic field causes an attraction of opposite poles. The magnetic field pushes the coil's south pole to the north and the north pole to the south, making the coil twist. The magnetic field's presence is indicated by this arrow. The magnetic field is present until the coil reaches the position modeled by this arrow. Once the opposite poles align, the magnetic field is no longer present, causing the coil to complete the rotation. The magnetic field comes back when the alike poles align again. The magnetic field being turned off allows for the coil to spin. Once as the magnetic field makes the opposite poles align, the turning off of the field will make the position and direction of the coil change so that it drops from its position where alike poles align and the magnetic field is turned on once more. Once it is turned on again, it will complete its half rotation. So right here, these are my force diagrams. This is when it is at rest. Force normal on the coil from the paper clips is when it's resting, just simply here. The paper clips are here and here. And this force of gravity on the coil from the earth. Right here, while it's in motion, these two forces are similar, but they are not balanced. And as you can see, there's a new force, and that is called torque. Alright, that is my simple motor explanation. Thank you for watching. Thank you for your time.